Hello, in today's video I'm going to discuss electrical power unit 12.5. Also take a look at the lesson up link to, or not link, but lesson where all of this is explained just in a different way. This is by far the most difficult unit that we are doing. Let's take a look what is discussed. In this unit, electrical power is introduced, and it starts by explaining what that is, which is when you use an appliance, energy is transformed from one form into the other. You might know this term power, or you recognize maybe the unit watts. When you want to know how powerful, for instance, blender is, you look at the amount of watts it transfers, it transforms. So the higher the amount of watts, the stronger the engine is. In pink, you see the formula, and below that in green a worked example. This is not so hard. Moving on, the way you calculate power is explained. In yellow, some general information. They took care about an artificial heart, and in the did you know box there is some more explanation about this artificial heart. In orange, you see a number of definitions that we have seen before. To come to the definition of the power supplied is the energy transferred to it each second, and it is the appliance. Then some more examples, and on the second page, this is I find the most difficult. At the top is still some explanation. Then one could say sort of a statement: when charge flows through a resistor, electrical energy is transformed into heat energy. Later on they say this counts for any appliance, electrical component, and then think of your charge of your phone. When you leave that in the socket to charge your phone, also that becomes hot. So some of the electrical energy is transformed into heat. Below this, an explanation is given for how you can calculate the electrical energy supplied by using current, resistance, and time. And they use two formulas and combine these. On the right here, I've worked out the maths, and you don't need to know this this year, but if you are interested in physics, then you might like to understand this. Otherwise, it's just good that you know the two formulas and you can use these. This explanation is also given in the lesson up. I'll explain it real quick. You have two formulas to start with. Then you you actually have three. So these first two are combined to make this one. Then you use Ohm's law, written as V equals R times I, or other way around, I times R equals V. And you substitute V to get twice an I, so this I and that I, and then you have that squared, I squared R times T equals the energy that is developed, or the heat energy developed in the resistor. Hopefully this is clear. Here are the key points still. What I want to point out here is that electrical power is per second, while the energy transferred is for a total time. That's why you multiply the power times time in seconds. Good luck studying this last